Hey guys, sorry I couldn't be in class today. I've done a little recording of my presentation so you guys can see what I've done. So here's an outline of my process for the logo replacement, not including the blending and that extra stuff. I'm going to talk about each of these points. So I decided to use the starting point of project number 4. I thought that would save me some work, and there are a couple of reasons why I thought a lot of the feature detection stuff that we learned wasn't really necessary. First of all, the logos, whether it's the flyers or Google, it's a lot less variable than a lot of the examples that feature detection are designed for. There's so many different ways a face can look, but there's not that many different ways a flyer's logo can appear. And they are a bit more difficult than the image mosaicing photos that we used, but I thought I could account for that by making some changes that I'll talk about. So the first thing I knew I definitely needed to get was scale and variance for the feature descriptors. That's because you've got that quite large Google reference image that needs to be able to match any of the little small Google logos on the bus or the smartphone or ones like that. And so you can use SIFT or something like that. What I did was just turn one feature descriptor into several. So for each point, I actually made 10 different sized feature descriptors, all of them resized to 8x8 and spaced out 18% apart by the side width. And I found that was enough for it to recognize any size. I only used 20 feature points for any of the logos, and I felt that was enough. So really that doesn't end up, so that's just checking 200 different feature descriptors, not too bad. I haven't implemented rotation and variance yet, but I think I'm going to do find the direction of the maximal gradient and just rotate everything in that direction. Another capability that I thought would help a lot, especially with logos, was adding color information to the feature descriptors. I think as for Google and the flyers, there's definitely color in those, and it's pretty much invariant across different logo instances. So what I did for that was, instead of having the one 8x8 square for each feature descriptor, I had 3. I had one for each color channel. Also, like I was saying before, I noticed that the logos weren't reproduced exactly as they appear. There were slight differences. Maybe one was, the one from the previous year or something like that. And so in order to compensate, I had to relax both of the thresholds that I used in the image mosaicing project quite a bit. And a similar problem is that in a lot of the images, you have different color backgrounds, whether it's major or just slight differences. In these examples here, these are the really tough ones. You have completely different background color to logos, which makes it very difficult. And I haven't implemented this yet, but my solution that I'm planning to add is a kind of background color invariance to the feature descriptors. My plan is to reduce the importance in the sum of squared distances calculation, to reduce the importance of the white pixels in the reference image. So obviously we can have curved surfaces or magnifying glasses, and so we need to go beyond just the projective homography that we used in image mosaicing. Like a lot of other people, I think, are also doing this, just a 5-point TPS. Probably don't need to explain this that much. So here are some of my results that I got from running my program so far on some test images. You can see on the left there, that's the really easy one. Then I've got in the middle kind of an example where it's very projective. And then on the right, it's kind of tricky, low contrast. That's number 9, I think. I wasn't able to do any of the ones with the very different color backgrounds. And I haven't implemented the 5-point TPS yet. So I couldn't do the warp ones. Obviously, I haven't implemented background removal or color correction or any of the really nice extra things that you can get to make it look real. So I hope you liked some of those ideas. Thanks for listening. If you have any questions, you can email me. My alias is JSM. And thanks. Good luck, everyone.